Okay, so good morning, everyone. So welcome to computer programming course. So yeah, there are questions on. There is the homework one already posted. I'm clarifying it. So every at the end of every lecture, there will be one small homework that will be posted, and that homework will take let's say a maximum of 1 hour to do the homework. The idea is to see that whatever the problems that are given in the homework, they help you understand the concepts discussed in the class. That is the idea. So the homework is posted on the eLearn, that is our course website. And the submission instructions we will let you know. So don't worry too much about the points for the homework, etc. I really want you to use that homework to enhance your understanding and use that as a pointer to explore more. Use that homework as a pointer to explore more. The submission instructions will be provided by today. By end of today, we will provide the submission the submission instructions. So there will be some marks, but as I said, no, don't worry about it. So my intent is not so much about grading you. So I want you to learn. So if you do it and then if you understand the homework is very small, you do it, you submit it, you will get 1 or 2 points for that homework. Okay, so don't worry about there is some weightage to it, but I expect each and every one of you to be able to get full marks on it, because it's essentially to help you understand. So there are questions on attendance, please repeat, and all those things. See, this whole video is recorded and it will be posted uh, on the course website by today evening. And attendance will be taken. Those of you who have logged in, it's automatically the attendance will be recorded. So I will not be taking the attendance explicitly. So when you log in, the attendance is already recorded. And we will not be using Microsoft Teams so much. Primarily, we will be using Zoom. If necessary, we will see if there is any necessity for using Microsoft Teams, we will figure out. We will use it. Okay, I think, see, there are few questions. So right now, let's focus on this today's lecture, right? So let's focus on today's lecture, and later on after today's, see, you don't need to log in anywhere. You are already in the session. Once you join this Zoom session, your attendance is marked. You don't need to log in anywhere. So number one on attendance, once you join this Zoom session, your attendance is marked automatically. You don't need to do anything else. And I will not be calling out your names and taking attendance. You can use your name, don't worry, okay? Use your full name. So if you use your name, it will be good because I will get to know you. Because if you use your roll number to log in, I will not know you. No? So it will be nice. If you ask a question, it will be nice to know your name. So please log in using your name. That should be good. So don't use your roll numbers. Roll numbers is, if you logged in using roll number today, it's okay. For attendance purposes, it's either you log in with your name or with your roll number, it is all right. But I would like to know your names. So please do log in with your names. So it's all right, guys. So let's not waste our time too much on all this attendance. Okay. So again, so I think I want you guys to hold all your questions on homework submission, on attendance, all these things. So let's get started on nice stuff. Okay. So let's get started. So so there is a twofold goal for today's lecture. The first is to understand computing systems uh, from a high level perspective. Okay, 10,000 feet view of computing systems is what we would like to obtain in the first part of today's lecture. And in the second part of today's lecture, I would like to introduce you to C programming using a very small example. That's the goal. So if you take any computing system, uh, if you take any computing system, it consists of hardware and software. Any computing system, it consists of hardware and software. So for example, if you see you are running your a web browser on your laptop or on your desktop. So the web browser is the software, and the bare metal laptop or the bare metal desktop is the hardware, like the display, your box, your keyboard, your mouse, your webcam. All these things, they constitute the hardware, and the software is your web browser or the Zoom client using which you are watching this video lecture. Similarly, if you think of your mobile phone is also a very powerful computer. And so what you hold in your hand, no, that is your hardware. Okay, what you feel and what you see in your hand, that is the hardware. But whereas the different applications running on your mobile phone, they constitute the software. For example, WhatsApp application, or even you can run the Zoom uh, client on your mobile phone and watch this lecture. And the third example is, for example, you go on Google and you give a search query. What happens to that search query? The search query that you give, it goes to the Google data center, and it has to search billions of web pages to find out relevant web pages corresponding to your search query. So what happens is in the Google data center, it consists of so many tens of thousands of machines. And so here you are sitting and your search query goes via internet. So this is the network. So via network, your search query goes to Google data center. So here so here you are sitting, this is your computer, and you gave a search query, and it goes to the Google data center. And in the Google data center, there's a massive parallel search operation will be launched. And all the relevant pages associated with the search query, they will be obtained and they will be ranked. And the results will be sent back to you. So here, if you go to the Google data center, if you think of what is the hardware that is present on the Google data center, all these tens of thousands of machines that are present on the Google data center, they constitute the hardware, and the search algorithms which run on these different machines, and the consolidation algorithms, that is, which take the search results from individual nodes and merge them and send the result back to them, that constitutes the software. So your Google data center, it's an example of a large scale distributed computing system. So in this course, we work on machines, single machines, like all the programs that we run, that we build, that we write and run in this course, they can run on only one single machine. But later on, maybe 2 years down the lane, when you take a course on parallel programming or distributed systems, you will be building programs, you will be building software which can run on multiple machines at the same time. All right. So no matter, and then one more example of computing system is, which is not quite obvious, is so now you have joined IIIT and you're all using webmail, right? Or so what happens when we use webmail? Webmail is a software. So it runs locally on the client, but then there is a backend that is the Microsoft data center where all your mails will be stored. So now if you think about this computing system, part of the software is running on your local machine and part of the software is running remotely on the Microsoft data center. So the Microsoft data center keeps track of all your user accounts, your emails, nicely organizes them so that when you log in into your email uh, account, it pulls up all that information, all the emails relevant to you, and shows them nicely on the local machine. So these are different examples of computing systems. But the most basic thing that we will be looking at in this course is, you have a laptop or you have a desktop with you, and we would like to write programs which can run on this laptop or desktop. So that is the setting for this course. That is the setting for this course. And now coming to hardware, any computing system, any computing system, it consists of three important components. One is called as a central processing unit. So one is called as a central processing unit, and the other is called as main memory or random access memory. We will see later why we call this as main memory or random access memory, and a bunch of I/O devices. So your CPU, main memory, and a bunch of I/O devices together constitute the hardware of your system. And then there is software that is running on the top of this hardware. So if you take a little bit deeper dive and see what this memory is. So we have the CPU here, and what are the typical I/O devices that we have? So one is display, your monitor. Number two, keyboard. Number three, mouse. And with all these virtual classes, two other important I/O devices are, one is webcam and other is microphone, audio. So now add to the standard list. So you have your webcam, audio, speakers, microphone. So these are the typical I/O devices that you will find on any visible I/O devices you will see on any computing system. So your CPU, what your CPU does is, it's the core compute engine of your system. It is what does the actual computations, CPU or processor. And how about memory? So if you think of your memory, so you should think of your memory as a linear array of bytes. Logically, we should think of your memory as a linear array of bytes. So I'm saying here, we say here it's a logical view, because physically the memory could be organized in a different way. The physical organization of the memory could be different from the logical view that we have. So what is the logical view that we have for the memory? That our memory is a linear array of bytes. What is a byte? A byte is a sequence of 8 bits. Like for example, here if you see, this is byte 0. So byte 0 is divided into 8 bits. So these are 8 bits. So byte 0, every byte, it consists of 8 bits. What is a bit? A bit is a one unit of information. Okay, it can be either 0 or 1. A bit can be 0 or 1, and a byte is a sequence of 8 bits. And what is your memory? Your memory is a logical, is a linear array of bytes. This is the logical view of memory that we will have. But whereas the physical organization of the memory could be different. So every byte in the memory, it will have an address. So this is the 0th byte. This is the first byte. This is the second byte. This is the third byte. This is the fourth byte, so on and so forth. And why is this called as a random access memory? This is called as a random access memory because the time taken to access any byte here is exactly the same. So uniform access time for any byte. The time taken to access the first byte versus the time taken to access the millionth byte, it will be the same. So that it's a random access memory, and it's the time taken to access any byte is exactly the same. So we have, so this is what is called as a uniform access time model. So, so if you have 2 power, so let's see here, if you take 2 power, so 2 power 10 bytes means 1 kilobyte, or we use KB as the notation. 2 power, if we have 2 power 10 bytes, 2 power 10 bytes, we call it as 1 kilobyte. So there are a couple of questions here. What does accessing the memory mean? So good question. So when the processor is, so what we will see later on. So when we switch on your computer, your processor executes a sequence of instructions. And these instructions, they are present in the memory. So the processor has to fetch the instructions that are present in the memory. Like for example, there could be some add instruction present here, and the processor wants to get that add instruction. So what it does is it using this memory controller, it goes and it tells the memory controller, you know what, I want to, could you please get me the instruction that is present at the memory address 1. So, and then, so the memory controller fetches that 8 bits of data, 8 bits of information that is present at that address and sends it back to CPU. That is what is called as a memory access. Similarly, as a part of execution of the, as CPU may want to fetch some data that is present at some address. So the CPU will ask the memory controller, hey, I want to access the data that is present, whatever the bits that are present at address is 6. So the memory controller will go and get that address and send it back to the CPU. This is what is called as a memory access. So this is the first question. The second question is, so why are we having 0x1? So I'm writing this in hexadecimal form. So when we write the numbers in hexadecimal form, we put the 0x at the beginning. So we will talk about hexadecimal numbers in a later class, but for the time being, you can ignore this 0x and think of this as byte 0, byte 1, byte 2, byte 3, byte 4, byte 5, so on and so forth. The third question is, can you tell a little bit more about system bus? So let's not get into system bus here, but just think of it as this way. So if you think of your computing system has a CPU, a bunch of IO devices, and a memory module, and all these things have to be nicely connected, and they will be connected through this what is called as a system bus. Later on, when you do a course on digital processors or in computer systems organization, you will know more about the system bus. For this course, all you have to understand is in any computing system, if you look at the hardware, you have the CPU, you have the memory, and you have a bunch of IO devices. And most important thing is this memory model. So what is this memory model? Think of your memory as a logical uh, sequence of bytes or linear array of bytes. So this is the most, if there is the most important thing for you to keep in mind in this slide is your memory is a linear array of bytes. So again, so you have all of you have many interesting questions like what is a system bus? How does CPU asks RAM for any data? So if you get into those details, we will take a different direction. So you have to hold all those questions and abstract away the details. So the way you learn computer science is having the right abstractions. So if you try to dig into every abstraction, then what happens is digging into every abstraction takes us into a different direction. So you have to abstract things away at the right level so that you can get your work done. Okay, like for example, when you sit in a car, and so if you want to learn driving the car, so what is the abstraction that you have? The abstraction that you have is you have the steering wheel, you have the brake, you have the clutch, you have the accelerator. So that is the model that is given to you. You should use that model to learn the car. But on the contrary, if you try to understand, no, like if I turn the steering wheel, what happens to the wheels? And if I change the gear, what happens underneath? If you try to get into those details, you will never learn the car. So you have, but then of course, if you want to design a car, you need to know all those details. So take, so you have to uh, come up, we need to have good abstractions, we need to have good mental models so that we can proceed. So towards that, so the questions related to what is system bus, what is, no, like how does the CPU asks for memory, all those details we will hide away. We will not worry about it in this course. All we understand is CPU can ask memory controller, hey, I want to access, can you give me the fifth byte in the memory? And the memory controller will give the fifth byte back to the CPU. And if CPU wants to write some data to the fifth byte in the, or 10th byte in the memory, it can tell the CPU, I want to write this particular value in the 10th byte in the memory, and the memory controller does the job for it. So this is the abstraction we need to have in mind. And think of your memory as a linear array of bytes where each byte is a sequence of 8 bits and every bit is either 0 or 1. And the time taken to access any of these bytes is exactly the same. So this is the model you need to have in mind. So shall I proceed? Are you all with me so far? Good. Yeah. So what is the execution model of the processor? So now we have the CPU. So now we will just take away the memory controller in between. So CPU can talk to the memory, So what is the execution model for the CPU? So CPU contains internally a special purpose register called as program counter, which we call it as PC. PC stands for program counter. So PC contains, this program counter contains, what does this program counter contain? So this is your program counter count. This is your program counter. So it contains instruction address, some address actually. So it contains, so whatever the address that is present in the program counter, this is your program counter. Whatever the address that is present in the program counter, so that will be sent to over this bus. That will be sent over this bus. And the instruction that is present at that address will be sent back to the CPU. This is what is called as fetching an instruction. Whatever the address that is present in the program counter, the address can be like 1000 or 2000 or 10,000, whatever may be the address. That address will be sent to the memory, and the memory will respond back with the instruction that is present at that address. And then what happens is, so once the processor gets that instruction, it decodes the fetched instruction. So hey, so the processor got an instruction. It checks whether it's an add instruction, whether it's a multiply instruction, or whether it's a subtract instruction. Whatever that instruction is, the CPU tries to understand. This is what is called as decoding the fetched instruction. After decoding the fetched instruction, the processor knows what it should be doing. So if the instruction is an add instruction, the processor does addition operation. If the instruction is a subtract instruction, then the processor does subtract operation. And there are other kinds of instructions which are called as control transfer instructions. We will see what these control transfer instructions are later, why they are useful later. But at a very high level, because you will be studying this in a course called as Computer Systems Organization. And then there are third kind of instructions which are really interesting. These instructions, they read data from the memory to the CPU, or they move data from the CPU to the memory. These are called as memory transfer instructions. And then after the fetched instruction is decoded and executed, the processor goes to the next instruction and executes the same. So there is a interesting question. So does the PC fetch one at a time? So for the sake of simplicity, let's assume that the length of all instructions is 4 bytes. Okay, for the sake of simplicity, assume all instructions are of length 4 bytes. So what it means is, when the processor puts the address, the address of the current instruction on this bus, the 4 bytes starting from that address will be fetched. Like for example, if processor keeps 0x address 4 on the bus, then what happens is the byte at address 4, address 5, address 6, and address 7. Sorry, this is 6, this is 7. So the bytes that are present at addresses 4, 5, 6, 7 will be fetched and sent to the CPU, because we are assuming that the length of the instruction is 4 bytes. All right. Are you all with me here? And then finally, when we are going to step 1, what happens is, before going there, so PC is equal to PC plus 4. So you want to increment. So because the next instruction will be present at address 8, so at a offset of 4 bytes, so you increment the program counter by 4. So the moment you switch on your computer, this is what your computer, your processor does. It fetches an instruction, it decodes the fetched instruction. What does decoding means? So decoding means understanding what the instruction is, whether the instruction is an add instruction, whether it is a subtract instruction, whether it is a branch instruction, whether it is a read instruction or a write instruction. All these details, the processor tries to, this understanding of what the instruction is happens in the decode phase. And then after that it executes. Once it knows if the instruction is an add instruction, it knows how to carry out the execution of the add instruction. So it does that computation. And after it does that, it increments the program counter by 4 because we have assumed that the length of all instructions is 4 bytes. So this entire process takes place for each instruction. Chinmay has this question, this whole thing about fetching an instruction, decode, execute, all this is, think of it as on a per instruction basis. And the program counter automatically means it gets advanced. The processor increments the program counter by 4 in step 4. So before it goes to step 1, so what happens is this increment of program counter happens. That is PC is equal to PC plus 4 happens here. Incrementing means, so program counter, it is a kind of a structure. It's a memory. Think of it as a kind of, let's say, the program counter is a kind of 32-bit register. So your processor contains what are called as registers. They can hold some information. So your processors, they contain registers. They can hold some information. So program counter is one of the registers. So in that program counter register, so the address of the instruction that needs to be executed will be there. So let's, there are some interesting questions. Let's see. So our previous instructions, let me take the questions. So first question is, what exactly does increment in PC means? Increment means, like at the end of step 3, the first thing is, let me make it clear, your processor contains some registers. So these registers are like kind of the memory of the processors, internal memory for processors, internal memory for processors, these registers. So among those registers, program counter, it will have many registers to do different things. Among those registers, your program counter is an important register, which contains the address of the instruction that needs to be executed. And so after you execute an instruction, so you have to make the program counter, increment the program counter so that the program counter contains the address of the next instruction that needs to be executed. There is a question, are previous instructions cleared or just kept in the memory? So no, the previous instructions, the instructions are not cleared from the memory. And there is an interesting question from Kush. By what method the instructions are stored in that address in the first place? Very good. So I will answer this question in a moment, Kush. The bit can contain, so Divyansh, so the bit means, bit can store either 0 or 1. Okay. So using that you can represent a variety of things. Okay. But all a bit can represent is 0 or 1. When the Gaurav has this question, when the increment happens, if the first instruction was at 0x4, then when will it read the next instruction at 0x8? So Gaurav, as you can see, so initially, let's say let's say if when you go back after step 4, when the program counter gets incremented to 8, so we go back to step 1, right? So we go back to step 1. So then the instruction at the memory location 8 will be read. So Amey has a very good question. So after executing the instruction at address 12, is it possible to go back to an instruction that is present at 8, at the address 8? Excellent question, Amey. It is possible. And that is what this branch instruction do. Like for example, you can have a branch instruction. So branch to 0x4. So if the processor executes this branch 0x4 instruction, then what happens is the program counter, instead of going forward, what happens is you jump back and execute the instruction that is present at the address 0x4. So that is what these control transfer instructions do actually. Will the PC have only starting value of the instruction or the entire address of the instruction? So again, good question, Lokesh. The program counter contains only the starting address. Like for example, as I said, so if program counter contains the address 4, then but the instruction is present at the memory locations 4, 5, 6, 7. So the program counter doesn't contain 4, 5, 6, 7. It contains only 4. Nice. Why would each instruction need to be saved? So you will see that, Chinmay, because you may have to use those instructions again. So yeah, so the instruction will be there as it is. You don't need to save the instruction. Whatever the instruction that is there in the memory, it will be there until you overwrite it. So do the length of the instructions differ? So for the sake of this discussion, we assume that the length of the instructions are the same, but in practice, the length of the instructions could differ. So Kishore has this question, or on boot, where or what is the first instruction read from? Is it always the same? Awesome question, Kishore. I'll answer that question. All of those computations and transfer controls, are they also stored in binary? Exactly. All these instructions, no, we are saying add, subtract, branch, call, all these instructions, they will have equivalent binary representation. Like it will not be like add in the memory. So there will be an encoding for add. Like for example, add may be encoded like 0101101. Okay. This could be an encoding for the add instruction. So all the instructions, finally your processor can understand only zeros and ones. So because of that, so everything finally gets encoded in a binary form which the processor can understand. So the processor will get, so Shashwat has this question, even if you assume that each instruction is of 4 bytes, shouldn't the CPU need to go through all those 4 bytes to get the full instruction? The CPU doesn't go through all those 4 bytes. The memory fetches all the 4 bytes and gives to the CPU. And the CPU uses all those 4 bytes to understand what the instruction is and carry out the execution. So again, there is an interesting question. This memory we are talking about, does it have only instructions to be executed? What about the general files we have stored? Excellent question. I will answer that. This memory that contains all the instructions is our RAM or our permanent memory. Let's see. There are tons of questions. Okay. So I would say hold on to these questions, uh, and I will answer all your questions. They will be clarified. Okay, nice questions. All are very valid questions. But one thing I forgot uh, is this. Let me see. In the previous slide, so we were talking about the size of what are bytes and so here let me review this once, and then I'll answer. We'll go ahead and then I'll answer all your questions. So first thing is, so if you have 2 power 10 bytes, so these things you should 2 power 10 bytes is 1 kilobyte, and 2 power 10 kb stands for kilobyte, is 1 megabyte. 1 megabyte, and 2 power 10 megabytes is 1 gigabyte, and 2 power 10 GB is 1 terabyte. So if you see in terms of bytes, 1 megabyte is 2 power 20 bytes, and 1 gigabyte is 2 power 30 bytes, and 1 terabyte is 2 power 40 bytes. So you may have seen the size of the RAM, the size of the memory, the size of the RAM here. It is usually like on desktop machines, it could be like 8 GB RAM or 16 GB RAM. This is the typical size on the desktop machines or on your laptops. So if you go check your laptop, most probably you will find that the size of the RAM on your machine is either 8 GB or 16 GB. Or some may even have 32 GB, but 32 GB is like kind of higher end. But but servers, machines which are used in data centers, they can have even more memory, like 64 GB or 128 GB, etc. But that's the kind of the max. But on the contrary, if you look at your hard disk, that's what we will talk about in a while. If you talk about your hard disk, the size of the hard disk is like, for example, 256 GB, 512 GB, 1 terabyte, like that. That's the size of the hard disk. So what is the difference between hard disk and this main memory? We will see in a while. All right. So now let's see what is a program. A program is a sequence of instructions along with the necessary data. And so that the data can be present as a part of the program. So you will see when you are writing C programs, let's say you are writing a program to compute the area of a circle, and you want to use the constant pi in it while computing the area of the circle. So in that case, the pi value is encoded as a part of the program itself. But sometimes the data can be present in a file. You want to read the data from the file, do some processing, and write the data back to another file. So the data can be part of the program, like for example, the pi value in while computing the area of a program to compute the area of a circle or circumference of a circle may want to store this constant 3.17 as a part of program itself. or it can be provided external to the program from the files. Like for example, you have stored all information about students and their marks in a file, and you want to know the student, what is the average marks of the students. You want to write a program to compute the average marks for a given exam. So the data is present in a file. You want to write a program that reads the marks present in the file and compute the average. And of course, data can be generated as a part of execution of the program. Like for example, you have written a program to convert color image to a grayscale image. So you consume the color image maybe from the file, and then you compute the grayscale image, and you want to write it back to the file. So a program can consume input externally, and a program can generate output as a part of its execution. So there are few questions here. So I will answer these questions again in a while. Are you all with me here so far on this? So just a suggestion. So you have a few bunch of questions. They are all interesting questions. So hold on to those questions. You will get answers to those questions either in this class or at a later point in time. So don't let them block your, hold on, block you to go further. So they're all interesting questions. We'll answer them either in this class or in a later class.
Sir, I am trying to answer some of them.
So a program is a sequence of instructions and associated data. And each instruction is a sequence of bytes. And data is also a sequence of bytes. Every byte is a sequence of 8 bits. So you can think of your whole program as a sequence of bits. So your whole program is a sequence of bits. Your program is a sequence of instructions, and each instruction is a sequence of bytes. And data is a sequence of bytes. And every byte is a sequence of 8 bits. So you can think of your whole program as a sequence of bits. So this kind of answers a bit about the kind of questions you are asking. So all your program is initially present on the hard disk. So this is present on the hard disk. Like for example, if you are using Windows, you may know that you want to use Internet Explorer or Firefox or Chrome browser. So the browser program, the executable of the browser program is present on the hard disk. So we call this as the executable. What is an executable? The executable contains the instructions of the program. So the executable, the instructions of the instructions associated with your browser program, they are present. So the instructions associated, so there are some interesting questions. I will ignore them for the time being. I'll answer them again at the end of the session. Okay. So the instructions associated with the program, browser or editor, whatever it may be, they are originally present on your hard disk. So what is your hard disk? Your hard disk is it's a storage device, and it's a non-volatile storage device. This is very, very important. That means if you switch off your power supply, if you shut down your laptop and you reboot again, the file that you have stored on your hard disk still remains the same. And then, and the time required to access a particular location in the hard disk depends on variety of factors. So there is what is called as a read-write head. Depending upon the position of the read-write head, the time taken to access a data on the hard disk could vary. Like for example, here, there could be a data present here, and there could be a data present here. The time taken to access the data item that is present here and the time taken to access the data item that is present here, they may have different access times. So it has hard disk has a non-uniform access time. But the important property is it is non-volatile. All right. And so there are two kinds of physical structures we use for this non-volatile memories. One is called as HDD disks and other is SDD. HDD, and these are called as secondary storage structures. Secondary memory or secondary storage structure. Whereas your memory is usually called as primary memory. A homework problem for you is to figure out the difference between HDD and STD. STD stands for solid SSD, not SDD, it is SSD. Thank you for correcting. So I want you to find the difference between SSD and HDD. So all your program, it is initially present on your hard disk, and then you give your program for execution. Like for example, on Windows, you may double click on an icon associated with a browser. So what happens is when you double click on the icon associated with the browser, the instructions and the data that is associated with that program that are present in the executable, they will be transferred or loaded to the memory. So you can see, so you have your instructions, you have your data. Okay, so when you double click the icon associated with Chrome browser or Firefox or Internet Explorer, the associated instructions present in the corresponding executable, they will be loaded into the memory. After the instructions are loaded into the memory, the program counter register in the PC, it will be made set to the first instruction of the of your program, and then the CPU starts executing the instructions of your program. Are you all with me here? This is a very important process. Initially, the instructions of the executable, they are present on the hard disk. You double click that icon, and then what happens is the instructions associated with that program will be loaded into the memory. And then after that, control will be transferred to the first instruction of the memory of your program. How is the control transferred to the first instruction of the program? By putting in the program counter register the address associated with the first instruction of the program. This is what happens when you execute a program. So this is a question that is asked just now. So who loads the program from the hard disk to the memory? So you have double clicked that icon, and then the instructions associated with that program are loaded into the memory, but who loads it? Okay, so what happens is when you double click the operating system kernel, that is your Linux operating system or Windows operating system. So in that operating system kernel, there is a software component called as loader. This loader module of the operating system kernel loads the data, loads the instructions from the hard disk to the memory and sets up that program for execution. This is what happens. But then you may have this question, who loads the loader? How will the operating system kernel, and the loader that is present as a part of operating system kernel gets into the memory? So the answer to this is there is what is called as a basic input output system, BIOS. And this BIOS, so this resides in a what is called as a flash memory. So flash is a non-volatile memory. So this flash is a non-volatile memory. and it is randomly accessible. It's a non-volatile random access memory. So when you switch on your computer, what happens is control transfer goes to the first instruction in the BIOS. And then what happens is in the BIOS, there is what is called as a micro loader, which can load the operating system kernel into the memory and sets up your system for the rest of the execution. So the BIOS contains a microloader. That microloader loads the operating system kernel into the memory. And then from then on, the operating system takes care of everything. Whenever you want to execute a program, the operating system pitches in and loads the instructions of the program you want to execute and puts it in the memory. So these are the components of the computing system. So we have the hardware, CPU, memory, and IO devices. And then on the top of this, we have the operating system kernel. This is the most important part of what is called as a system software. The software that is present on your computer, it can be classified into two types, system software and application software. So operating system is the most important component of the system software. And then there are compilers, libraries, editors, etc. They also kind of uh, are part of the system software. And then what is the application software, like your browsers or any other programs that you may write? They are the application software. So in this, as you in so this is your first course here. So as you progress through this through different courses through your 4-year program here, you will be studying different components of this stack, like how do you design CPUs, how do you design an operating system kernel, how do you build a compiler, how do you build libraries, how do you build application software using databases or web servers, so on and so forth. So you will study the whole stack during your stay here in Triple IT. So BIOS is, there's a good question. BIOS is only used during startup. Okay, that's all. So after that, the operating system can take over. Roughly speaking, that's true. So to conclude today's lecture, uh, so if you open up your desktop, the dabba, the tower, and if you see inside, so you will see what is called as a motherboard. This is what you are seeing here. No? This is what is called as a motherboard. On this motherboard, if you see this is a CPU. There is a slot, small CPU. It could be 1 inch by 1 inch size. Okay, this is CPU. So this will go and sit here. And then where will memory sit? So if you see DIMM slots, there is one DIMM slot here. I think there's one more DIMM slot. So your memory will look like a chip like this. This chip you go and plug it in these DIMM slots. So you can see on the memory, you can see there are multiple chips present. So we have seen the logical view for the memory, it is a linear array of bytes, but the physical organization of the memory could be different. And one more thing is, unlike the hard disk, your main memory, it is volatile in the sense if you switch off the power supply, whatever that is present in the RAM, it goes off. But whatever that is present in the flash RAM, it still remains the same because flash RAM is a non-volatile memory. And how is your hard disk connected? So your hard disk usually doesn't go directly sit on the motherboard. What happens is, you take the hard disk. So let's see, where is the connector? So you will see some connector for hard disk. Yeah, this is the IDE connector. So you take this, so this hard disk will be connected. So this is here and this is here. So they will be connected with this cable. Good. So you have your motherboard, you have the CPU, you have the main memory, you have the hard disk, and then we can connect, no, you through USB, you can see, like for example, some places through which you can connect USB, that is your keyboard also you can connect your display, so on and so forth. IDE, good question. So in this context, what is IDE? IDE, you see, in software is different from this IDE. I forgot the extension for IDE, but it is a protocol for connecting IO devices. Okay. So the summary of today's class is, so in today's class, we have seen what are the different components of a computing system and what is the execution model. This is what we have seen in today's class. And and the reading homework, the questions for you is know about your computer. What is the processor? What is the size of the main memory? What is the type of secondary storage structure? Is this SSD or HDD? What is its capacity? All these things. Usually the capacity of secondary storage structure is in the order of 256 GB, 512 GB, 1 TB, like that, whereas the size of the main memory is like 8 GB, 16 GB, etc. And then one interesting thing I want you to do is, I would like you to read the laptop buying guide at amazon.in at this link. So you will understand many nice ideas there when you read this thing. And there are a couple of videos on BIOS which I posted on edX, which I will publish it after this lecture, and you can read them. So with this, I conclude today's lecture, and I will take all your questions now. Okay, so see the class, don't worry about, I don't want any questions on class logistics. The class logistics, please send an email. So we will send you the link for the class recording and all those things. I would like you to, I want to take other questions. Yeah, don't worry about, so I want you to understand these questions. But there's a homework posted. The homework will help you answer these questions, find answers to these questions. Again, no questions on logistics. I want to look at your questions. Those of you who want to drop off, the class is over. So, so you can drop off, but I will, but if you are, but if you have questions, I will ask. So first question is, I'll take questions. I want you guys to hold back for some time. Don't ask any more questions because there are many questions already in the chat box. So I will take one question in the reverse, one question at a time in the reverse order. Is the flash memory integrated into the CPU? No, Lakshmanan, sorry. The flash memory is not integrated into the CPU. Frame, what happens when we issue a new instruction to an already filled memory, or the instructions dynamically located? I think the flash memory is present on the motherboard. Somewhere on the motherboard it will be present. I think so. Yeah. What happens when we issue a new instruction to an already filled memory? There is nothing like issuing a new instruction. So it's a very involved question frame. So but I will give a simplistic answer. So this is your memory. So this is your memory. Let's say this is your RAM. So let's say some program is present here. Some program is present here. Let's say, yeah. So what happens is after this program gets executed, this memory will be released. This memory will be released. And so let's say if some other program, let's say this is program P1, and this part of memory could be occupied by some other program P2. So once a program gets executed, the memory associated will be released. And then let's say if this is released, P1 finished execution and it is released. And you asked operating system to execute program P3. So operating system will override the instructions associated with P1 and put the instructions of P3 there. Oh, drawings are not visible. Let me see. How about now? Can you see? I'm just scribbling here. No? Let me do one thing. So just a quick question. In the class, you didn't see any drawings of me, or how is it going? In class you saw. Okay. Then what happened now? So stop share. Let me reshare again so it may help. Let me use here. How about now? Can you see?
Yes, sir, we can see.
Yeah, so this is what I'm saying. Let's say there's a program P1 given for execution, and then there is a program P2 given for execution, and then there's a program P3. So this is your memory. So when you give program P1 for execution, the instructions of P1, let's say they are present here. And then you gave program P2 for execution, the instructions of P2 are present here. But after P1 gets executed, after P1 is done, the memory associated with P1 is released. The memory associated with P1 is released. So now when P3 comes for execution, so P3 will override the memory. The instructions of P3 will override the memory that is allocated to P1 before. Yes, exactly. So the OS has the right to overwrite, release, relocate memory as and when it needs. Exactly. So this part is clear. Nice. So flash memory is non-volatile and it is usually in the size of 1 MB, 2 MB, that, or maybe 16 MB, that kind of. So Gaurav has this question which is bugging him. Could an instruction go, for example, 0x4, 0, or it has to be in order? No, what do you mean by that, Gaurav? I mean, when you say an instruction go to, so Gaurav has one bugging question. I didn't get that question, but I will answer other questions which, yes, flash memory is separate from RAM physically. Can multiple programs be run simultaneously? So yeah, it is possible, but it happens in a very interesting fashion. Why is RAM memory is very less compared to hard drive memory? Good question. See, RAM is very expensive. Okay, so if you want to buy, so think of when you're buying your laptop, you go for 8 GB RAM and try to go to 16 GB RAM, you will see that there will be 10,000 rupees difference, or maybe 15,000 rupees difference when you move from 8 GB RAM to 16 GB RAM. So that is one. Second is The access time for the RAM should be extremely small. In terms of nanoseconds, it should be there, because the CPU will be executing millions of instructions per second. So your RAM should be able to supply data at the same rate. So if the size of the RAM becomes very large, then supplying data, finding the data and supplying the data to CPU becomes hard. Okay, but so two things: RAM is very expensive. Number two, we have to have a control on the access time of the RAM. But whereas if you look at hard disk technology, that so you can even buy it 10 terabyte storage structure at relatively cheaper price. Okay, so to put it differently, 1 terabyte of G memory hard disk you may have on your laptop, but if you want 1 terabyte of RAM on your laptop, it's not possible. You may have to shell out few tens of thousands of dollars. What we have a loop in which P1, P2. Good question, Chinmay. Chinmay has a very good question. Um, See, what happens is in practice, this is what happens. So your time multiplexing happens. Your program P1 executes for a while, and then program P2 executes for a while, and then program P3 executes for a while, and then program P1 executes for a while. Like that, it keeps going. Does it answer your question, Chinmay? Oh, again, drawing is not visible. Let me do one thing. New share. So Chinmay has this question: if there are three programs, and so let's say there is one CPU, then what happens is P1 executes for a while, and then P2 executes for a while, and then P3 executes for a while, and then again P1 executes for a while. Like this is how it goes. So if only starting value instruction is stored, then in case length of instructions is different, how will it know where to end each question? Very good question, Lokesh. So I tried to avoid that question. So what happens, Lokesh, is in if the length of instructions are different, usually what processor does is it fetches the first byte and it knows what is the length of the whole instruction based on the first byte, and then it issues the corresponding request. That is how it does. Doesn't the CPU tell the memory how big the program is? The CPU, it's not exactly how that works. The operating system knows the size of the program, and it will execute and it will take care. How does it remember where it left P1? Yeah, see, I think so. All of you, all the questions, let's stay. We should take a pause here. All the questions that you have are very, very valid. You will not be learning all of computer science in one lecture. So I think we should pause here. Okay, we should pause here. But every question that you have asked, they are all valid questions, but each question requires a very detailed answer. I cannot hand wave them. Uh, so, but what I want you to understand from today's class, to summarize, so for those of you who are here, still here, is this. I want you to understand, in every computer, you have CPU, your RAM, okay, and your bunch of IO devices. This is one. The second part is the execution model I want you to understand. So what is the execution model? You fetch an instruction, you decode an instruction, and you execute the instruction. This is the second. The third is the memory model. Your memory is a linear array of bytes. Think of your memory as a linear array of bytes. So this is your memory, and this byte 0, byte 1, byte, so 0, byte 0, byte 1, byte 2, byte 3, so on and so forth. And when you give your CPU is here, this is the summary of today's lecture. This is your memory, this is your RAM, and this is your hard disk. Your program is initially present here. When you give your program for execution, this will be loaded into the RAM. And then the processor starts executing the instructions of that program. So this is the summary of today's lecture. You are not able to see anything, whatever I have written? How many of you can write? Yeah.
No, sir, I cannot.
So did you get the summary of today's lecture, please? This is very important. This, what I have mentioned here, I want you to understand. I understand you have many other questions, but this, what I have written here, you should understand. CPU, RAM, IO devices, fetch, decode, execute. Your memory is a linear array of bytes. And yeah, so, and when you give your program is present on the hard disk, you give the program for execution. The instructions of the program will be loaded into RAM, and the CPU starts executing. See, all questions related to, I will stop the recording here. All these, you will get a mail with the recording of today's, where you can find the recordings of today's lecture. You'll get it. Okay, I'm stopping the recording. So all books, I will give you books, everything, all necessary resources I will provide, don't worry. And don't worry about homework upload. I told you, I will send out an email for on the same, okay, where you can upload the deadline, etc. Good. So yeah, so I would like to insist, don't worry too much about this other secondary things. Try to get a very good understanding of the computing systems. Okay, this is the lecture I really want you to understand. I want you to appreciate the ideas, get in depth, get a feel for them, and other things like like where to submit the homework. All those things I will send it. Okay, to you. Okay, awesome, guys. Thank you. So we will tomorrow 2:30 you will have your first lab session. So given what I will do in the lab session is, in the tomorrow's lecture, in the tomorrow's 2:30 to 3:30 session. So 2:30 for half an hour I will take introducing you to the basic C program structure, and then after that you will do one small exercise, and then that will conclude to the goal for the tomorrow's lab is everyone should be able to compile your program and execute your program. That is the goal for tomorrow's lecture. So that is all from my side today. So thanks a lot for joining. So I look forward to be with you for the rest of the semester. And someone told that they want to ask the question by enabling the speaker. So be it. But yeah, that's fine now. Yeah.
Hello, sir.
Yeah. So if you
Good.
want to enable your microphone and want to talk, please feel free to do so.
Hello, sir. Am I audible? Hello, sir. Am I audible?
Okay. I am not able to hear.
Sir, am I audible, sir?
Yeah, I could not hear. Sorry, guys. I don't know. I think there's a question. Oh, is it? Let me see what's happening on my microphone. Hello?
Hello. Hello, sir. Can you hear me?
I should be able to hear. Let me see.